Hello, everyone, and welcome to this course about collaborative environments, and in particular the private aspect of blockchains. I'm Alexandre Moreau, and this course comes courtesy of Blockchain Secure, the company I work for, and Télécom Sud Paris, which I'm currently doing my PhD in. So this course was given to Master 2 students, but is for all general purposes. When you arrive in the world of blockchain, it can be quite overwhelming. There's a lots of tools, and it's hard to understand what you need, what can wait a little bit, and what does what. As simple as that. So hopefully you'll be able to follow this course, and by the end of this, have your own private blockchain running. To do this, there's a couple of prerequisites, so make sure all of those are good on your end. Number one, you have to make sure that either you have a Linux subsystem. Macs actually work nicely now. You can just work from the terminal there. If you have Windows, you will need a VM, so make sure you have a Linux VM installed. If you have a Linux VM installed, it can be a good idea to use WinSCP to move files easily from your system to your VM subsystem. From there, just make sure you have at least Java 11 installed. Check the version for that, and the Java Development Toolkit. That's pretty much it. So it's pretty straightforward. As long as you have some basic understanding of programming and moving around in Linux, it shouldn't be too hard. The first thing you'll want to know, if you're using your VMs and your IPs a little bit, make sure that you know which ports are used in your system. So I'll be using ports by default, but if you know that you're using those ports for something else, you need to make sure that you're changing those in the exercises we'll be doing. Okay, so let's start this. First of all, the scenario we're going to do, we're going to sort of a little bit of a role play here, is the following. We have Alice, Bob, and Charlie, and they work for different companies. And for reasons X, Y, or Z, they want to create a collaborative environment and a blockchain to work. So why would they want to do that? Well, blockchain allows a number of advantages, although this is not what we're going to talk about. It allows records to be immutable. It allows for data to be stored completely securely in a way that cannot be modified. It allows to have also a very secure history of the files, because on the blockchain, as you might know, every single node contains the history of the entirety of the blockchain, which can be very interesting. Maybe they simply don't want to rely on the trust of a third party to execute transactions. Maybe they want to run decentralized applications. There's a lot of things they could do with blockchain. So in this case, Alice, Bob, and Charlie would obviously be probably at least miles apart. In this case, we're going to be running Alice, Bob, and Charlie's nodes directly on one single IP address, one single server. But essentially, it works the same way. And we'll try and move those in different files, so we're able to identify clearly what would belong to Alice, what would belong to Bob, and what would belong to Charlie. Before we start actually running some code, let's first take a look at blockchain. This isn't, of course, a general course about blockchain, but let's make sure we have the basics down. Blockchain is a decentralized ledger. If you know anything about blockchain, that's probably it. It's a system of, a network of nodes where every node has the entire history of the blockchain. And those nodes come together to create new blocks. And all of these blocks obviously get stored in every single node. And these blocks need to be validated. And once they're on the blockchain, they are immutable. It doesn't matter who you are on the blockchain. You can't go around modifying previous blocks. That can't happen. Those blocks are linked together, in particular, by the block that is right before them, by a system called the hash. You probably know a little bit about hashing if you're here. So if suddenly a block gets modified, that hash doesn't match anymore yet, and that chain is broken. So that can't happen simply. In this case, we're going to be using Ethereum as our blockchain, and quoted directly from their website. Ethereum is an open source, public, permissionless peer-to-peer network of distributed nodes that send and receive transactions, validate those transactions, and remotely execute smart contract scripts. So there's lots of keywords there. It's public, it's permissionless, that's suitable for private applications. Well, we're going to be answering all those questions, but obviously the answer is yes if you're here. Public essentially means that you can, if you wanted to open your own node on Ethereum, you're very welcome to. In fact, that will make the Ethereum system stronger, as redundancy tends to make blockchain systems more resilient. Permissionless simply means that, once again, you can't just come to the blockchain system and be the boss and change previous nodes around. And we can work for private applications. Before we go any further, we need to understand, when a blockchain creates a block, how should we want this block? How to reach a consensus to where this block is the block we want or we need? Now, the two main consensus algorithms are proof of work and proof of stake. Bitcoin, who really made the blockchain arrive on the public scene, runs on proof of work, and so does Ethereum for now, although Ethereum is starting to lead its change into proof of stake with Ethereum 2.0. Just very interesting. Proof of work essentially creates a problem, a mathematical problem, whose difficulty depends on the number of people trying to solve it. So a bunch of computers are going to try and solve that problem, and the first person to reach a solution is given the right to validate transactions. It's more of a obviously, people don't mine in the objective of validating transactions. They mine it because validating transaction gives them compensation. So it is very inefficient. You're literally creating a problem that doesn't have inherent value to it, just for people to spend a lot of time and energy to solve it. And from there, once they solved it, we just put that problem apart, and they just get rewarded, and they're allowed, and they have to validate your transactions on the blockchain. It is very, very hard to scale. In that sense, we can say that Bitcoin was a little bit a victim of its own success, because if you wanted to start mining Bitcoins, which is the action in which you put your computational power towards solving these problems, you needed to have an absurd amount of calculation power, and the more people try, the more energy everyone spends, so the prices skyrocket, and the electrical bill at the end is absolutely ridiculous. It's also not a fair system at all. It encourages pooling, because if you're alone with maybe your one server, your one computer, you're not going to get anywhere close to solving one of these problems. So people would create server farms that would allow to run these things. In fact, I believe I've read somewhere, you might want to double check me on this, but that 4 pooling farms in China had more than 50% of the computational power of Bitcoin, at least for a while. So yeah, definitely not a fair system. It also is vulnerable to 51% attacks. It means that if you have at least 51% of the computational power, you could, quote unquote, take over. You could have a majority in and validate blocks that maybe aren't supposed to be validated, or vice versa. Obviously, the defense against that in things like Bitcoin is the sheer size of the system. If you wanted to own 51% of the computational power, you would have to spend billions and billions. Okay, anyway, let's move on to proof of stake. Proof of stake was created to try and combat these problems of efficiency and scalability. In proof of stake, a user gets a chance to create a next block depending on what he put at stake. So he puts a certain amount of tokens, or essentially money, at stake, and those funds are frozen. He can't just use them around. And depending on how much he put at stake, the higher he put money at stake, the higher the chance that he will get to validate the next block. And that happens depending on the amount the number of total amount of tokens that were put at stake. Sorry for the little fumble there. Here, one validator, once the validator has been chosen, he doesn't get extra reward on top of the transaction fee. So here, the incentive that he runs the blockchain properly is because he has a lot at stake. If he doesn't have a lot at stake, he will very, very scarcely have to do anything. If you have a lot of stake, you definitely have a lot to lose, so you have to run the blockchain properly. Here, the 51% attack would not work, simply because, well, if you stake at least 51% of the amount of tokens that exist, well, you're putting at risk 51%, and you can potentially win only 49%. And then also, in the action of acquiring those 51%, the market of those coins would explode, and you would end up paying a lot of money to get them, and eventually you can't even get anything. In fact, I remember reading the sentence, which it was very clear to me when I read it. A proof of stake miner is limited to mining the percentage of transactions that are reflective of his or her ownership stake. As easy as that. And in fact, I haven't mentioned this, but essentially what was happening with proof of work is that it's created a sort of pseudo proof of stake. Because by pooling, what people would do is when a pool would manage to mine successfully a Bitcoin, they would then split it evenly in between of the quote unquote stake people put in that pool. That means the computational power they put at disposition. So that sort of created a proof of stake, but where it isn't the system that makes sure everything's fair, but people running the pool. So it sort of defeats the purpose of blockchain. Although I mentioned it quickly, why would somebody go through the effort of spending a lot of computational power to validate the transaction? Well, in proof of stake is to ensure the system you invested in stays stable, because the more you have at stake, the more responsibility you have. And in proof of work, you get rewarded by gas. Gas measures the amount of work a miner has to put to include a transaction inside of a block. Every time you're going to run a transaction, you're going to give a gas limit and a gas price. The gas limit is as much gas as you're willing to invest. If you don't have enough gas, your transaction will not be included in the block, but you will lose that gas, like a little bit like in a car. If you have too much, the accident will be refunded to you, so you are incentivized to put a little more there. Gas price is as much as you're willing to pay for your gas. Miners decide which transactions to validate. So if you're not willing to pay a lot for your gas, your transaction will have very low priority in the eyes of the miners. If it has a high gas price, people might want to do that. Paying gas requires you to have wallets and everything. So there is a level of abstraction that was added by GSN's is. Oh, wow. That's quite bad, actually. I'm sorry about that. It is gas something network. Okay, I completely forgot about this. So GSNs are essentially network of nodes, validators, and people that will have the service set up where they will handle the gas part for you, and all you need to do maybe is space restriction or get back to them in some way or another. So you could potentially send those things without having to dabble in gas. Well, anyway, this is a little more advanced, so if you were able to say what GSN was before when I stumbled on it, you probably don't even care very much about this part. But today we are not going to be using any of these consensus algorithms. We're going to be using proof of authority. Proof of authority allows individuals to become validators, and the way they do that is tying it to the identity. So you are incentivized to run the blockchain properly because it's linked to your reputation. If you're validating blocks that are not supposed to, you will ruin your own identity. So it's very important, and you don't need to be behind your screen validating all these transactions manually. The process is automatic. Another part is you can't approve consecutive transactions, like you can't handle consecutive blocks, so that also incentivizes to avoid one person just absolutely screwing everything over in the blockchain. And indeed, it does avoid a shortcoming of proof of stake. In proof of stake, your power only depends on how many other people put at stake. If I have $1 million and I put at stake $100,000, then the system doesn't know I have $900,000 at my disposition. So I can definitely maneuver things to make sure that I get more out of the money that I haven't put at stake. So here, it's not only what you have at stake that's taken into account, it's everything you own. In particular, although it does exist in a certain number of public blockchains, it is very, very suitable to private and test blockchains, because you can just make sure that things are validated to run, maybe test your smart contracts, stuff like that. So there we go. Before we get into the demo, what is a private blockchain? Although it's quite intuitive, the open aspect of blockchain is not tied to the blockchain by design. By nature. It is by design. We just decided that it would be something that should be public, and it came with some ideals of avoiding centralization. But essentially, a private entity can absolutely create a blockchain where if if they don't want you to become part of that blockchain, they can absolutely stop you from. I know that JP Morgan Investments has been leading in the blockchain for a while. In fact, I believe they've just bought Hyperledger, which will be using a lot of Hyperledger today. But in particular, even Walmart has been trying to track the provenance of a lot of its products using the blockchain. Comcast is trying to manage to do some privacy-friendly advertising by using ZKP. ZKP is a zero knowledge proof. It's a way for you to prove you own something without having to show it or show the information that's inside it. Let's say a country would want to prove they had a nuclear power or nuclear weapon without showing other countries everything about it. Well, ZKP will allow them to do that. Obviously, that's just a classic example to show what's at stake, and usually it's something a little more down to earth. So running a private blockchain allows you to run a much smaller system, so it's very effective. And in Ethereum, your transaction would take a minute to validate just because of the sheer size of the system. Here it's very free. And because it's smaller, not only can run more transactions, but each actor gets to run more transactions proportionally. So that's also very efficient. It allows you to have inherent backup because every single node contains all the information. And it allows you simply to tailor your solution to whatever you want to do with the blockchain. The cons were it's inherently less secure because there's less actor. As easy as that. And obviously, you don't have all the public aspects. You don't have as much redundancy. But hey, if you decide to run a private blockchain, you probably have a use that does not require other people there. A small note is hybrid solutions are possible. It is possible a little bit like intranet. If you're in a private company and you have an intranet, you still have access to the internet, don't you? Intranet being an open system and intranet being a closed system. So there's ways to create bridges from one to the other, although that is not what we're going to be looking at today. So hopefully this little introduction, this little preview helped you understand what blockchains are and how they work. Now it's going to be a matter of doing all of this ourselves. The laboratory part of this course, we're going to actually start building our own private blockchain. So the first thing we're going to do is use an Ethereum client. So if you don't know what an Ethereum client is, a client is an implementation of Ethereum. It's going to be whatever is running your own node. It verifies a transaction, it keeps the network secure and the data accurate. So here, Alice, Charlie, and Bob are definitely going to want to run their own nodes. And if they wanted to run multiple nodes per person, they could. If they wanted to have one node for multiple people, that's called multi-tenancy. There's very interesting things to do with multi-tenancy. But let's assume they just each want to open one node. Now, one of these is going to have to be a boot node. The way that these nodes manage to connect to each other is by saying, hey, here's the address of my boot node. Here's the person I want to connect to. And then that person is going to connect you to everyone else. So here, maybe Alice, Bob, and Charlie would have to say, Alice is going to be our boot node, but it does require inherent trust. Another way to do it is that if you have another party, let's say, creating the blockchain for you, maybe they're running their own boot node. And then everyone refers to that boot node to connect themselves. Now, in that case, you do have an extra node in the system, but as we'll see later, it's completely possible to keep all your information private from that node. So it's a way also to start your system without having to rely on trust. So I'm going to be skimming through this part relatively fast because there's a wonderful tutorial done directly on Besu, which is right here. It will be linked down below in the description, but if you follow this, you'll be able to achieve what we achieved. So I'll be going through it a little bit, but it's going to be, if you need more information, definitely come here on Hyperledger Besu. They have wonderful documentation, which makes it quite easy to approach. If you're ever wondering, ivft is a consensus that uses proof of authority. So ivft 2.0 is what we're going to be using. Hello there. It was so obvious I almost forgot to mention it. Before doing any of this, you're going to want to install Besu. From there, just type download Besu binaries. I download from binaries. You just download however you want. From there, if depending on your system, I want to do different things, but here you do install from package binaries. grab the package binaries, and from here you have all the most recent releases. You're going to want to take the most recent one, take it, unzip it, install it. So there's some configuration files that we're going to be needing. Actually, this is a little intimidating, so let me just go back to the other. This is what we're going to be using. So we're going to create a little file called ivft network. And inside, there's going to be a configuration file. There's going to be dossiers, directories. I'm sorry, my French side is coming out here, for each and every node. So here, because we're running all 3 nodes on one same machine, non-likeliness, there's going to be another one for node 2, another one for node 3. And inside these directories, you're going to have a configuration file, although this is not strictly necessary. We'll talk about it in a second. And data, which is the public key, and the private key, which are inherent to blockchain because you need to encrypt the data. First thing we need to talk about is the ivft config file. It is very, very important. Not only does it contain general configuration about your blockchain, here as you can see, we're telling him, hey, we're running ivft2. You're telling him lots of things like the ID, and here's some general configuration. It also contains the the wallets that you can be initializing. So say, here are the wallets and here are how much they have. Something that is very, very important to understand, and that took me a while when I started on the blockchain, is that accounts and nodes are not related. That account happens to be owned by whoever has its private key. And it's also very important to understand is that we can't create money. The sum of these balances are going to be the total amount of currency ever available on this blockchain. So in this case, we created 3 accounts. So maybe these would be Alice, Bob, and Charlie's account, but not necessarily. Maybe Alice does not have an address, an account, and maybe Charlie owns 2 and Bob owns 1. But very, very importantly, more importantly even, in the ivft config file is going to be a genesis file. So if you followed a little bit and you know that in a blockchain, every block is related to the previous block, well, then there has to be a question, right? What's the first block? How can it depend on something before? Well, if you're running on the mainnet and you want to go on Ethereum, well, he's going to handle that part for you. But if you're creating your own blockchain, then you actually need to sort of create that first block manually. And that's what the genesis is. The genesis is a block you create manually. And because that hash is going to be used for the next block and the next block and the next block, it is absolutely fundamental that every single node in the system has the same genesis. And when I mean the same genesis, it's the same exact file because it's going to be hashed. So there can be, even if there's a typo, someone can say, oh, there's missing an S here. It's absolutely impossible. It has to be the same character by character. The cool part about this is you're not going to have to write any of this. You can copy paste it directly from the from what we have here. Second part in configuration file is bezu.conf. When we're going to launch our node, we're going to have to tell him a bunch of information. First of all, what's the data path where he can store the data? In this case, we created a little directory just for this. Where's the Genesis file? Genesis file is probably going to be created automatically from your ivft config file when you're going to start everything. You're going to need to tell him, this is my boot node, as we mentioned earlier. It's very important to tell him where your boot node is. That's how he's going to connect to everyone. Then the ports he's going to be using. As you will notice here, the whitelist is everyone. I haven't mentioned this maybe closely enough, but all of this is for test purposes. If you need to run actual private blockchain, you probably need a source other than a tutorial on the internet. Make sure here we're going to have some private keys directly that are not encrypted directly on our files. We have complete whitelists, so make sure that you are aware that this is just for test purposes. And then there's this port. So this port will likely be available on your machine. If you know that you're running other things, make sure that you're putting a port here which is available. There, so before we move on to anything else, I guess we can move on to actually installing these things. So here, I already have an ivft network, so what I'm going to do is to make a directory. Let's call it ivft/n, but you might want to create directly a network. And I'm directly going to create a first node, that contains data. So let's move into ivft-n. And from here, I'm just directly going to make my 3 nodes. If you wanted more or less nodes, it is completely up to you. Here, you just create as many nodes as you want. And we're going to do it for node 3. So here, if we take a look at what we have our 3 little nodes that each contain, actually, if I even tree it, could all contain data. So now we're going to need that ivft network. So what we're going to do is you're going to arrive in this little beauty of tutorial on Bezu's website. So this first part we've already done. They have 4 nodes, we just happen to have 3. And here is your file. So let's understand a little bit what's in there. So this is general configuration, as we mentioned earlier. These are the accounts that we're going to be using. So just copy that, and we're going to create, as they mentioned, just ivft config file.json. So we're going to nano ivft config file.json. Let's make sure that we're ivft config file.json, and that we copy everything in there. Then from there, we want to copy. And so once again, just to walk you through, this is now what our arborescence looks like from here. From there, we just follow this. Here, we're going to have to create those keys. Obviously, we're not going to type everything manually, and we have this was going to do it for yourself. So let's take a look at the parameters here. First of all, you're going to tell him where that configuration file is. Well, we just created it, so that's good. And then we have to tell him where to arrive. So here, all the files we're going to create are going to arrive in network files. So we're probably going to have to move those from network files to each and every node. And we're going to tell him, hey, the private key, put in a file called key. And that's why we arrive. Actually, no, sorry. Yes, sorry. So our private key is going to be created in the key file. So from here, you can just copy it directly from Bezu's website. And bam, all we need to do is paste it. So it's going to take a little bit of a while to generate all those keys. Let me do this. And. Oh, because sorry. So here, first example, let's make sure that we create things properly. So what I'm going to do here is our ivft configuration file and delete it, because what I did not do is ivft. So how are we creating it? There we go. There was 2 capital letters that did not take into account. That's very important. ivft config file .json. And inside, as we mentioned earlier, I think I copied something else in the meantime. I'm going to copy this, and it's going to stay there. So I already had one of those files created, so hopefully on your side you didn't have that happen without an error, in which case this is probably what's going to happen. There you go. And now if we look inside our arborescence, we're going to have network files. So if we move into that, it's going to contain our genesis.json and our keys. So from here, what we're going to want to do is copy that genesis.json into our arborescence. And if we move into keys, let's see a little bit what it looks like. You have all of these nodes, which here were created for this purpose. So they have an extra one, or we're just going to use 3 of those. And these are in fact still directories. So let's maybe move into any one of those. And it contains key and key.pub. So all I need to do now is copy those files. So the Genesis file goes here. Oh, actually, I should put it here. So after doing this, you're going to have here a Genesis file. And you just copy the keys into the data of each and every one of your nodes. So here, once again, we created 4 because the tutorial had 4. I'm using only 3 of them. If you're using a number, just adjust that. And from there, actually, you know what? Let me do it. I'll do it all on my own time to not take any one of yours. And let's touch base in a second. Hello again. So hopefully by now you've created all these files and copied. So if we look in our side, it looks just the way this looks. So these are a little bit redundant, but they're still the network files. But in fact, all of these files are inside your nodes. And outside the nodes, you have your configuration file and your Genesis file. So if you have that, congratulations, because now the only thing you have to do is to start your node. So this first node, node 1, is arbitrarily the boot node. So this is going to make it start simply. And as we saw here, that command weirdly looks like what we put inside of our configuration file. Well, that's exactly it. But before we check that, let's first try to run our node. So hopefully just copy that. And it did not load Genesis because I did not start it from node 1. So indeed, you first need to go into node 1, and hopefully now if you go, because here it was looking for something and the directory was right above it, and obviously above it I was outside of my file. So as we launch that, hopefully now it should just start. There we go, and now it's running. There. So here, what you obviously it can wait for peers for a while because no one is trying to connect. So from here, let's try and run a configuration file, shall we? Because every time you're going to want to run that exact command, that can be a little bit, a little bit heavy, and we don't need it. We don't need any of it. So what we can do here is create a configuration file. Let's call it bezu.conf. We put it in node 1. It's quite important. Each one is going to have. Let's just copy the command for now. Obviously, we're not just going to put the command in there. But what we can put, let's do this, and we're simply going to put every single one of these options in here. So as we can see here, we have the data path, the Genesis, and everything. Now you don't need any of these. You can just go here, copy, and just copy all those options, and hopefully have a file. I'll leave you do that in a second, and we can define ourselves again. So from here, I just modified slightly our configuration file. One thing I should have mentioned is you should definitely put everything in strings and when needed in arrays. I will have those linked down below, so if you just want to copy and paste them, you're welcome to. I'll probably do the same thing with the Genesis file. So here I put all the ports you will be running on. These, I think, for the first one are by default, but then if you do this for the first one, you might forget them to do with the other ones, and then you're going to have port conflicts. It's going to be a whole mess. Once again, just make sure these ports are available on your machine. So from here, as opposed to using that big command line we used right before, now all we can do is just tell him what the configuration file is, and he'll look for all those on himself. Then we launch this, and it is going to start running. Wonderful. So here at the beginning, there's something you're going to need to look for in those logs. It's enode URL, and you're going to want to copy that, including the enode column --. Bam, that's copied. Don't copy loaded public key. Make sure to copy enode URL. And there we go. This is running. Now we're going to do pretty much the same thing for someone else. As you can see here, he's waiting for peers, but no one's connecting yet. So we're going to make sure someone connects to him. Now we're going to do the same thing for our second node. So you're going to have to open another terminal because this needs to stay running or else your node just stops. And you're going to open a configuration file. And you're simply going to copy. And a lot of things going on here. You're going to want to copy your file. So here, what I'm going to do just to make sure that you're not lost is bam, bam, bam. We're going to copy the exact same configuration file as that first one, right? Let me just copy my enode URL here. Oh, did I? I did not. Yay, wonderful. Let me quickly get it here. There we go. Bam. And let's paste it in here so we don't lose it, shall we? And from here, let's do like this. Bam, bam, node 1 /bezu.conf. And let's just copy paste this one. So from here, all you need to do is copy paste it from the description. You don't need to do any of this mess. And here we can do this. And we are going to paste it. So this is the exact same thing as you had above. So now if we try to run this, it's going to tell us, hey, those ports are being used right now. So we're just going to add 1 to these ports. Once again, make sure that those are available on your machine. There we go. And now something that we did not do for that first one, because that first one was the boot node. But this second node is not the boot node. So we're going to actually have to tell him, you have to connect to this guy here. And if you check in here in the tutorial, On this first one, there's nothing of the sort, but when you start the second node, you have to tell him, hey, here's the boot node, and then you're going to have to tell him the URL. Notice that there's an S here, there's a boot nodes, because you might want to run multiple boot nodes. As long as you have one boot node running, your system is running properly. But because it's boot nodes, boot nodes, that's not going to work. Boot, oh god, wow, today's not a good day for me. Boot nodes, you're going to want to put it inside an array, first of all, because it's going to be plural, and then inside of a string. And then inside this, all you're going to do is to take this little thing here, and then to copy it in here. Make sure it doesn't go down the line like I just did for me. And then you can take this off. So hopefully with those 3 little modifications, so 2 coming to the ports. Actually, there's one I forgot. I'm just noticing right here. There we go. Just add 1. And from here, once again, as opposed to using your big command line, you can just tell him where the configuration file is. Notice that here I am launching it from node 2. It's very, very important. And here it's bezu.conf. So here, there you go, it's starting. Oh wow, lots of peers because I have other things running here. So let's come check our first one here. Bam. And our first one just got people started connecting to him. So it's a little bit of a mess here, but hopefully on your machine it should be clean and you just have one peer doing the connecting properly. Maybe I shouldn't have. So RPC port. Yeah, okay, anyway. And now I have to do the exact same thing for node 3. So either just open a third one and simply copy paste this command. So let's maybe run another one. Let's just duplicate the session. There we go. And let's move into our right here. And from here, all you need to do is to go into your third node and to launch this, or I didn't copy it properly. That's on me. You can just copy it and launch it from here. Once again, if you're going to use it, I strongly suggest you create a configuration file. So here, as you notice, we appended one more to the P2P port and one more of the RPC port. Once again, you have to make sure that those are running. And you want to replace this enode URL by the URL of your first node. And once you execute that, you will have your first little private blockchain running. Congratulations. To run all 3 of your nodes, let me put them up right now. Config file equals bezu.conf. We know how to do that now. If you want to make sure that things are connected properly, there is a way to do so. Let me launch all 3 of my nodes. There we go. It's going to do a peer count, and that is simply going to count the amount number of peers a node has. And here's bezu config file up equals bezu.conf. Now all 3 are doing what you can do is run another session. So go. You can move into. You can do anywhere. It's to run this. So you're going to curl your local host on the port where a node is running. In this case, this is the first node, the boot node. And the method I'm going to use is peer count. You don't need any parameters and the ID is arbitrary, but you have to put something in there. Once you do that, here you need to make sure that this is not 0. Here he's telling me this is the ID I gave him. The JSON RPC is relevant, so the result you're interested in is this one. If here you have 0 or 1, it's a problem. Here he indeed has 2 peers which are connected, which are the 2 other nodes. So that's a good way to check that everything is launched properly. Now we're going to start building on top of that first layer of Bezu. In the first part of this tutorial, we learn how to run our little private Bezu blockchain. From there, you could absolutely run some transactions and do some things, but if you're here, you probably want some extra layers to that. One of those is probably how to run private transactions. So to run private transactions, we're going to use a tool called Orient. And that was so obvious I forgot to mention it, and I had to edit it after the fact in the first part. But before using these tools, you obviously want to go download them and install them. So in this case, just type download Orient, and you're going to arrive here. You're going to want to take the latest version, unzip it, install it, and from there, you can join us back. Now, Orient, what's quite interesting, quite important to understand, is that it is a layer above Bezu. So Orient nodes are going to be running as well as Bezu nodes in our system. So for each Bezu node, you can or cannot have an Orient node if you want to run private transactions on that very node. Once again, we just decided that it'd be one node per person and everyone would be running Orient. This is arbitrary, really. So the way we're going to do that is simply by creating these Orient files in every node. And once again, I'll be quite brisk with this because there is a very well done tutorial here that's called Configure a Network for Private Transaction that builds off of the tutorial we just followed before. So before we get into that, how the hell do you do private transactions? This is a blockchain. Isn't everything supposed to be public? Well, yes, technically. But what's going to happen is every time a transaction is going to occur, an Orient node who's going to receive it is going to check who it is meant for, and is going to check whether or not it has to transfer to Bezu. If it is concerned with the transaction, it is simply going to show the transaction to its Bezu node. But if it has nothing to do with that transaction, you're going to see a private tag. So if it's not meant for you, you can see a transaction has occurred, but you cannot see who it came from, who it's going to, and what it contains. You're going to have none of that. But to make sure the blockchain stays consistent, something's going to have to appear there. Now that we've learned a little bit about the theory of Orient, let's actually install it onto our little prototype. On our prototype, we can actually launch transactions right now. If you just wanted to with Bezu, they're not going to be private, but you can absolutely just use them. Now, if you want to send private transactions, you're going to need Orient. To do so, we're simply going to follow this little tutorial on Hyperledger Bezu's website. And it builds off of the previous tutorial, so you can just move from there. So let's take a general look at what's going on here. In each node, we're going to create an Orient file, a password file that's going to encrypt keys that are going to be generated by Orient. From there, we're going to create configuration files. Although we have to take the initiative of doing it ourselves on the first part, this time it's directly in the tutorial if you want to follow it. Then from there, it's just going to launch its own nodes from there. As you can see, once again, this first one is going to be sort of boot node. It's just a straightforward options here. And on these next ones, we want to indicate the fact that there's another, where the original node is, essentially. So let's do that. So let's open these three from there. So in node 1, I'm going to make directory Orient. And let's move immediately into Orient. Inside, we are going to create a password file. Make sure to capitalize that F if you're going to copy paste the commands later. Let's say our password is PW. Yeah, obviously this is a very bad password. You would not want to create a to do anything sensitive in here. This is obviously just for educational purposes. We're going to do the same thing right here. We're going to move in Orient, and we're going to nano password file. Inside here, just going to put PW as a password. So yeah, let's click. There we go. And finally, in here, we're also going to make dear Orient, move inside of it, create a password file. Inside of here, we place PW. Now we're going to generate the keys. To do so, all you need to do is Orient -G node key, which you can copy directly from the tutorial. Tap in here. It's going to prompt you for the password. And PW is the password we elected to choose. We generated it here for every single one of the nodes. PW again. And same thing for that third one. From here, we're going to create a configuration file in each one of them. We're going to start with node 1. So in here, we're just going to nano conf, and you can simply copy paste what's inside. Let's take a look at what's inside though. Here, it's just going to use the local host you're going to use to launch a node on port 8080. And here you're essentially telling him what the keys he needs to access are and the password to actually gain access to those, because it's encrypted by the password. So that's the basic information. We're just going to copy those in here. And those two other ones, we want to make sure that we have this extra option. So here, this is for node 2. So obviously, we can't put the same 8080 and 8888 because they're already used by orient 1. So we want to just add 1. Make sure those ports are available if you want to use them. I believe this is where I'm in node 2. Yes. From here, we're going to nano orient.conf. And from there, we're going to save this. And for the third one, you can copy paste. You can just copy and then change, add it one to whatever is needed. But there we go. Nope, this is the one we've already done. There we go. Copy, save. From here, this is the command to launch it. Now, what you're probably going to want to be doing is, using Bezu, you had to type -- config - file equals whatever configuration file. But here you can simply specify the file directly. So now, to launch your entire network, what's going to happen is that you're going to need 6 open terminals if you're just going to use 6 ports. I believe here they have like 4 Bezu nodes. So for each one of those, you're going to have to run. So I'm just going to run them. Again, so the only thing I did since I left you was launch my 3 Bezu nodes here in the background and open 3 new terminals of the orient nodes. So from here, all I need to do is to start launching them. Just make sure that you launch the one inside node 1 first, because you're referencing it in the other ones. So if they have nothing to reference, it's going to give you an error. So there we go. Let's wait for a quick second. And from there, if you wanted to interact with the blockchain, you would obviously need a 7th terminal open so you can actually act on it. Of course, this is a problem we're going to be looking to solve in the future. So let's orient.com and orient. There we go. And as you can see, when I'm launching these, we're getting some extra logs here saying, hey, someone is trying to access here. And that's how they're connecting one to another. So there we go. We now have a complete network using Bezu and Orient. In the next step, we're going to start adding some extra tools that are a little more advanced that are going to allow you to sign transactions. There's one more step that we're going to be doing before we start getting out of the blockchain and doing like more development side and actually playing with what we did, and that's ethsigner. Because when you emit a transaction, we know where a transaction was emitted from, not who it was emitted by. So it's very, very important to use signers. So in this case, we're going to be using ethsigner. There are a bunch of ways to sign your transactions. In fact, I think there's even a native way to do it using the Web3 library. So the way ethsigner is going to act here is it's going to act as a proxy. A little bit like the proxy we did for Apache. It's going to be a proxy between a user and a node. And from there, you can sign all the transactions you want. So here, what we're going to do is we're going to use that signer for all of our accounts. So everyone will be able to access it using the 3 accounts that we set up. Obviously, in real case, you would probably have one signer for one account, or maybe even multiple signers for an account if scenario were to dictate it. But in this case, we're just going to set up one proxy, and everyone who has obviously the private key of the account will be able to use it. So the way we're going to do that, it's a little more complicated, and there isn't like one clear. Like you can go on this tutorial to start ethsigner with a single signer, but I found it to be a little less easy to follow if you're a beginner than the Bezu and Orient ones. So I just made try to deconstruct it even more so it's as easy as it could possibly get. Before we start, obviously it's those things that are so obvious you forget to mention. Make sure you actually, go download ethsigner. So to download ethsigner, you can go right here, which will automatically take the latest version for you, or just type download ethsigner onto your browser, and you should easily find it. Once you've installed it, move into your home and then your user. So here, make sure it's that your user you're using, and just there you go, or else he won't be able to find it. You're going to unzip the zipped file, the archive you have there. You're going to move inside of it, and then just to check everything's fine, just tap -- version. If it gives you an error, you know it's the install wasn't complete. And if it gives you the version, you know everything is fine. And from there, you can move on with what you're about to see. One thing that isn't easy when you're not using transaction managers is to sort of keep a clear head of what's what. So here, I just copied all the addresses of the accounts here in this place. And I've just decided on a key for all of them, which I copied in here. So it's going to be easier to copy and paste them if you put them in maybe a Word file or anything, because then you're going to be head in your terminals. It can be quite hard to keep an eye there. So what we're going to do now is going to move into the ivft network file. So I think here I'm still in sudo, so let me get out of there. And I don't know where. There we go, home. So we're going to cd bcs and ivft network. I just called it ivftn if you remember, because I have another one set up. Here, you're going to make a directory called ethsigner. Yeah, so let me do it here actually. Called ethsigner. And from there, we're going to move it inside, and we're instantly going to create a password. So a clean way to do it is probably to do it like this. You're going to type your password, so it's going to give you a prompt. Up, there we go, copy it, copy that, there we go. And let's just do PW as a password. Do any password you want, but remember it's very important. Now what we're going to do is to create a JavaScript that will create a key file for us. Now that means you will need Node.js and everything, but hopefully if you follow the tutorial, it should be installed here. So Web3 and Node.js should be installed, make sure they are. And inside here, we are going to we're just going to copy this. There we go. Now notice inside here, I have the address of, actually, which one is it? There we go. Sorry, it is the key to the first account. So I just copied the key that I decided on right here. So now what you're going to do is you're going to run the script by typing node createfile.js. That's going to give you an output, and you're going to copy that output into a file that you would have created called keyfile_, and here is the address. So not the key, the address of the first wallet. So here it is. And you're going to copy that inside. Now you're going to go in here, and you're going to change this private key for the next private key. As you can see, this is already the last one because I did it with all three. So first we're going to run it with this. Copy the output and put it inside the key file of this one, create a key file for this one, change the key of the create file to this one. And you should have, let me show you here now that I've run it. Let's check inside the key file for, let's say, the one that starts with FE. You're going to have this sort. So this is the direct output I got from createfile.js. You're not writing anything here. This is quite important. So then what you do is you go back inside your create file. Here you change the key to the key of whichever one you want to generate the key file for, and then you put it inside the key file. It's quite straightforward. So now these three will be complete with the output, with different outputs. And now what you're going to do is you're going to create for each of the accounts a toml file. And in there, it's going to be mostly metadata. So the date isn't very important, to be honest. So you're going to copy all of this, and all you're going to do is to point towards the correct key file. So if I'm creating the one for FE3B, etc., I'm going to say, hey, the key file is obviously here. Place the actual row into your network file, and then from your network file, this should be the same as yours if you follow the tutorial. And you're going to point to a key file with the right account. So then you're going to create a second one with the second account. So as opposed to FE3B in here, you're going to put 6273, etc. The 0x's, actually, you might want to get rid of the 0x's here. It's just to point the fact that it's in hexadecimal. But let's keep them out of here for now. And you're going to create that second file with 6.2, etc. And you're going to copy the exact same thing. The only thing you're going to change is this. And you're going to put the 6.2 and whatever inside. So hopefully now your arborescence should look something like this. So you have 3 TOML files, which all contain metadata, which points to their key files, which are here. These are the 3 key files containing the keys. As you can see here, the password file that we use is the same for all 3. So you also have the password file here that is being used in all 3. And you still have the createfile.js, which I guess you could delete at this point, but if you wanted to generate any more, you could leave it there. Now, the last thing you'll need to do is to go in ethsigner version snapshot, which should be right here. Here you have an ethsigner snapshot. So we're going to move inside ethsigner snapshot, and you're going to launch this command. Now let's analyze this for a little bit of a moment. So first of all, inside here, we're going to put the chain ID that is in the configuration file inside the ivft config file that we did at the very beginning of this tutorial. So make sure it's the same one there. Then we're going to tell him on which port to give back the information he spits out. So here it's going to be give it back to node 1 on 8545. The port he's going to be listening on is 7545. Remember, this acts like a proxy. So he's always going to be listening on 7545. Whatever he gets, he checks out with the keys, everything is fine. He signs them and then gives them back to 8545. And here you're also just going to have to give him the path to directory where we just did all the work we needed, so that is in your ivft network. So just to be clear, this directory we're in is not in ivft network. It's in the same part. As you can see here, I have ivft network, and I'm in here. So now let's launch that. Bam, 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 bam. And as you can see, we now have to have 7 terminals open at the same time. And I have to open an 8th terminal to do anything. Okay, now that we have Bezu and Orient running, the next step is installing Apache. And actually, you can install any proxy and set up any proxy. I just happen to be using Apache. So if you have another choice, please go ahead. This has a number of advantages. Number one, it allows you to secure your connections because these proxies will be more secure than direct access. And second of all, if you want to access those nodes from somewhere else than the exact IP that they're set up on, you're going to need that. Let's say Bob wanted to maybe access a node that runs on a server he has at work, and he wants to access it from home while teleworking. He's going to need Apache. And it's also going to be in use a little bit later, so we can also set up some monitoring tools. So to do so, there's also a tutorial. So I try to compile here a little bit of what to do. So maybe if at some point you're somewhere down the line of this, you might want to simply pause the video and keep this in your head. So first of all, you are going to have to install Apache. I will let you do this. What you're going to want to do is to go in apache.configuration, which will be created in Apache 2 automatically, and copy this at the end of the file. So once you've done the pre-configuration everything, you should arrive inside the file here and simply copy these lines right here inside here. Obviously, this is home/bcs happens to be the name of the user I'm in, so obviously change the directory, but whichever name you're using. Don't just blindly copy that. The next thing we're going to want to edit is in the same file. It's a one deeper. We have to go in sites available. So as you can see, I'm in Apache 2 here. So I'm going to go in sites available. And then, did I just type nano? Yes, I did. That's my bad. Sites available. And from there, we're going to nano/default. before the end of this tag, you just want to add those two. Did I even write them? No, I don't think I did. So actually, let me do that right now. Let me do this and here. There we go. And add those two. We still have one little edit to make. So now we're going to want to go in sites available. So that's where we are right now. And we're going to want the nano bezu.configuration. And as you can see, I've already done there. You're going to have to create it using nano. Make sure you're also in a root to be able to edit all these files. Here I can't write them. And you're going to add all of this in there. So here we're dealing with Alice's node, although it says Bob in the slide. So we're using 8545, which is the node number 1, and we're going to make the make it accessible by the proxy bezu-n1. So do that, and when you are done, it's just a matter of launching. These edits you need to make as root. So to get into your root, just type sudo sup like I just did, and from there you actually be able to edit the files that we did. As you can see, maybe there was a little bit of a warning saying, hey, you can't write in these right now. That's because I was not as roots. Now, once you're here, this is actually the wrong file. This is for the next step. We're going to want to go in sites available, which is where we are right now. And suddenly he's going to know what this is. And you can type this, bezu.conf. Obviously, I've already done it before, so make sure that you do that. And you're going to do that also for default ssl.conf. Once again, already did it. Next thing you do is systemctl restart /2. We've just made a bunch of modifications. We want to make sure those are taken into account. I've typed, oh my god, I'm just typing a lot today. There we go. So obviously here it didn't say, hey, you've already done this, because it's just a simple reboot. Now just to make sure that it is the way we want it, just copy, paste that, and here, as you can see, we have active running in green. That's good. If it's not, make sure you did the prior steps properly. Now it means that we will be able to access that first node not only on our local host or by the exact IP you're using with port 8545 by typing 127.0.0/bezu-n1. If you wanted to set up some other proxies for your other nodes, just do the exact same thing by putting whatever proxy you want on whatever port. The next step is going to be installing monitoring tools. Indeed, it's quite hard to see what's happening on the blockchain if you're just relying on the logs. And as you can see, it's really messy. And because the blockchain has a property of having all information at every node, all you need to do is to see what's happening on one single node, and suddenly you have a great view of what's happening on the blockchain. Well, that's what monitoring tools are for. Now, there's a lot of them, but here we're going to be talking about Alethio Light Explorer, which we commonly refer to as Light, simply. It is a quick install, and it's going to allow us to really explore what's happening on the blockchain. So let's get into installing it right now. Now, I've already done this on my machine, so it might not be as walked through, but here are all the steps you're going to need to do. First of all, you're going to need Node.js. So if you don't have Node.js, have it. If you've worked a little bit with your machine, there's a very high chance that you already have it. Next thing we're going to do is actually install Ethereum Light Explorer. So you can simply clone it their GitHub and npm install. Now, here's the fun part. You're going to go into your Ethereum Light Explorer, and you are going to start editing the configuration file. And there's going to be, so let me open it here. So you're going to open config.dev.json. It's only going to become config.json a little bit lower. So you're going to edit it, and inside you're going to have a couple of plugins which you're going to delete. We don't need fcommon, 3box, flight, and ivft. There's going to be a little bit of a version. You can delete that as well. And in node URL in eth, so right here, if you check it out, there we go, in ethlight, you're going to put, as opposed to, maybe here there's going to be mainnet.infuria, maybe. you're going to put the IP address of the machine you're using, and here you're going to bezu n1 because we've established that alias when working with the with Apache a little bit earlier in the video. So once you did that, you're going to close this and save it, of course. And now you're going to have to generate it. If you don't do that, you will have a compilation error. So you're going to have to do these 3 exports, and then npm run build. After that, you might want to reboot your machine. And hopefully, from there, you won't need to touch this anymore. The next thing you're going to do is to stay in dist. Actually, let me leave that up. There you go. Inside dist here, you're going to have to install core plugins. So this is what you're going to have to copy. I'll put it on multiple lines. It has to be on one line when you're actually running it. So it's acp install, and here there's going to be the fcommon, flight, the fmemento, the 3box, and ivft2. So you run that. It's going to take however long it takes, depending on your connection. And from there, we can start making, finally going to change that config.dev into simply config. And to do that, all you need to do is to copy it directly in dist.config. Wonderful. So once you do that, there we go. So, sorry, I'm just checking quick something. And then you're going to move into dist n1 in case you want to create, in case you wanted to monitor multiple nodes, which you might want to do, for instance, to check the use of privacy tags. Because from one Explorer, you might have something showing, and from the other one, you see how much you can see when the transactions are private. So that's why, that's the reason here why I have dist n1 as opposed to just dist like you have. And that's why we created config.json from config.json. Now you're going to go in your root. So sudo su your way in there. There we go. And we are going to go in etc Apache 2 sites available. So you're going to have to go way back. So here I'm in my home. So we're all the way back. And if you go here, you're going to have your etc. So now we're just going to cd etc Apache 2, which if you've installed the same way I did, you should have also. So sites available. And from here, we're going to nano light explorer n1. So you're going to have to actually create it using a nano. Here it's going to open because I've already done it. And you're simply going to copy these things. So all you will need for now is likely this here. There's just a second one, but don't bother. All you need to copy is what is here. So you do not need this, just what's here and here. And that's pretty much it. So what that is going to allow you to do is to explore what's happening on the blockchain. So now I can simply type my IP and Light Explorer N1. Now there's one more thing that you might want to do before we actually start playing with the blockchain, is to use Docker. Now if you have a lot of experience with Docker, this is going to be obvious to you. If you have very little experience with Docker, this might sound a little bit dreadful. Now this is not a Docker tutorial per se, but what Docker is essentially, it allows you to put some of your applications and everything you need into containers, and those containers are much easier to deploy. They can have all the dependencies you need, and you make sure maybe your environment variables are there, and it's very, very, very useful. And the second tool that sort of goes with it is Docker Compose. Docker Compose is going to allow to handle multiple of those containers and launch them at once. So as we talked about earlier, here we need an absolute ton of these. So these are just running Bezu nodes. These 3 are running orient nodes, and here we have our eth signer. So let me actually just interrupt our eth signer to demonstrate what I want to do here. So this is, as I mentioned earlier, I've been running all this time creating a second file called ivft and working there. But the one I've been using to run my test called ivft network, and I've already docked everything. So let me show you a little bit quickly. If you know a little bit about Docker, you definitely want to go on Docker and to follow some basics or to watch some YouTube videos. There's a ton of them out there, but essentially a lot of it is going to come down to this Docker Compose. So let me quickly show you the Docker Compose I use, although I'm not going to go in depth about it. So there it says the Docker. So these are the environment variables we're going to be using for essentially all of the services. So we're sort of putting them there to make sure that we don't need to repeat them. We can, if we just need to change something, we can just change it here. It's going to change there. And in my services, which are essentially all the containers that I'm going to be deploying, there's the boot node. So this would be Alice's node as we use. The Alice's orient node is right here. Then there's going to be Bob's node. Bob's orient node. Wow, that's a lot harder to say than I thought. And there's going to be also Charlie's node, and as you saw, they each have an eth signer. So in this case, it's a multi-key signer. It can be whatever. If you only have a single key signer, it can absolutely be there. So in this case, it means that when I deploy this Docker Compose, it is going to launch all of that. So let me quickly show you. First of all, let's just interrupt all of these, which is an absolute joy. To go from having to launch everything manually to composing it's a little bit of a hassle to do it the first time, but once you did it, it's over. Let's hope. Maybe I should have interrupted them. I hope they're not running in the background. I don't think they are. So now, if you go inside the file, all you need to do, and I will show you here, is simply docker-compose up. And it's going to launch everything. So now my three nodes, the three orient nodes, and the eth signer is going to be launched simply by doing this. And we can even make it so it's in the background. I'll show you that in a second after I show you that everything runs smoothly. There we go. And we can have all the logs in the world. So it's going to be a big mess here in a second, I'm telling you. So obviously going from using all 7 to this is it's a pleasure, especially if you're going to be doing lots of tests, maybe seeing a little bit of blockchain, adding nodes, removing them, running smart contracts. You definitely don't want to be handling those manually. So you're definitely going to want to dog them if you're going to do any significant work on them. Okay, we've now launched our blockchain successfully using Docker Compose because it's much easier. We can now actually start watching our blockchain upgrade and trying to manipulate inside of it. First of all, now that it's running, first thing we can do is go check on our Light Explorer. Here, as you can see, these blocks are being transmitted. So all of these are individual blocks. Just so you know, I have a little bit of an interface issue here. So it's 37 seconds up. But because we have an Apache and a proxy, it means that, for instance, if I take my phone and I try to connect to it to go check this out, there we go. Here you can see, hopefully, that this says, let me maybe put this up, that we have 2 seconds ago, 3 seconds ago, 4 seconds ago, and every 5 seconds, bam, we have a new block coming. So that's really cool. And if we go inside one of these blocks arbitrarily, it tells us who validated these blocks, what it contains, the gas it used, etc., etc. Well, it's not really interesting as long as these blocks are empty, is it? So now let's check out what we can actually do inside of our blockchain. So here I kept it running, although you can absolutely run it in the background if you wanted to. That's just the -D option with Docker Compose. Let me put that out of the way. So one thing we can do, a little bit of a, so there we go. Let's move into our network, shall we? And the first thing you can do is to do a peer count method. That's probably the first thing you want to do when you start. And I believe we did a little bit earlier, and you make sure that that's above 0 or above 1. It corresponds to the number of pairs that you have in the rest of the system. And one thing you can do here is get balance. So here, if you get balance, the parameter is simply the name of the account. And remember, this time you do need the 0x. Here I am directly calling the port of a node. So here 8545 is Alice's node, if you remember properly. And if we run this, it's going to tell us this is the amount of ether inside inside this account. So remember, this account does not belong to Alice, it belongs to whoever has the key. So that's very, very important to keep in mind. But okay, now let's do the fun part, actually sending transactions from an account to another. So to do that, well, this is what we're going to use. We're going to use send transaction. So you can find it inside the documentation, and it's going to show you exactly what the parameters are. But quickly, from is obviously the account that you're coming from. To, I think it's quite self-explanatory. Gas is how much gas you're willing to put in it, and gas price is the price you're willing to pay for it. Here, because we're in private, if you put gas price equals 0, it will still run, although that wouldn't be the case on a normal blockchain. So this is more to illustrate, but if you want it to 0 to make sure your gas stays there, there's no problem. Notice that when I run transactions, the port I do here is not 8545. It's 7545, because on 7545, our ETH signer is listening. So by going back through 7545, he's going to be able to sign those transactions, which would not happen if we didn't go through this port. And if we didn't go through this port and try to do that transaction, the system would tell us, wait a second, this transaction is not signed, and he'd be right. So in this case, I don't remember exactly how much I put in every account, and we've been moving funds around with some students. But let's just try to copy this directly. Bad or missing URL. What did we? Oh, because I copied it twice. As easy as that. There we go. And here, the result you get is going to be a hash. So first thing we do, let's go check here and look at this. Every time we did something, it appears in our blockchain explorer. So it's going to take the time to confirm. But here you can see the hash of the block. It's parent who validates it. In this case, the gas limit happens to be 4.7 million, which we're probably not going to be reaching anytime soon. A normal transaction typically takes 21,000. By running some smart contracts, by deploying some smart contracts recently on this blockchain, I've seen gas usage around 3 million, but 4.7 million seems to be a little bit harder to reach. So that's good for us. So let's wait for everything to be confirmed, shall we? It always takes a minute. So the thing you can also do using Lithiolite Explorer is explore. And to explore, all you need is hashes. So you can explore for blocks. If you type the number of the block, it will show you the block. If you type maybe an account, we're going to do that in a second. And if here you had the hash of a transaction, you'd be able to directly search for the transaction depending on its hash. So let's go come back here. And here, if you take the hash, let's also cover this. A little bit of a mess here. I'm sorry about that. And if you copy it here, it's going to tell us, hey, here's a transaction. And we can simply go explore it. Here, you notice that the value is 0 Ether. And you're like, what the hell? We put something in value, didn't we? Well, something you have to keep in mind, there we go, is that these transactions are not in Ether, they're in Wei. And Wei is 10 to the minus 18th compared to Ether, and it's also in hexadecimal. So here, indeed, it tells us that we went from account FV to account 62. That's exactly what we did inside our transaction. And now let's try and send something a little more significant. So one thing we can do to directly check also the balances of our accounts is simply if you copy the account and you want to maybe in something that's a little nicer to watch than the terminal, I need to copy and say, here, we have an address here. This one happens to contain 179 Ether, and the two others contain a bunch of Ether. So let's try and send, let's say maybe 100 Ether. Like, oh, how would I do this? Well, to do that, obviously you're going to get a custom, but at the beginning, something that might be interesting to do is to use Ethereum converter and a little converter to move to hexadecimal. So let's say I wanted to send 100 Ether. So obviously it's just 18 zeros behind that, right? So let's copy this, take it here, enter a decimal number, convert it, and here we have our hexadecimal. So now we're going to run the exact same transaction. I'll change it directly in here, it'll be easier. And let's remember to keep 0x right in front of it, or else it will not work. The rest can stay exactly the same. So if you place it right here, I didn't copy it properly. There we go. Bam, new transaction. So let's leave it the time to confirm. Well, while that's happening, I'm also going to talk about gas. Because something you'll notice, maybe if you're doing a test account and there's exactly 100 Ether inside of one of the accounts, and you're going to try and run this exact transaction, and it's going to tell you it didn't work. And that's because gas has to be paid. And although the gas price is very, very negligible, let's try and put it into dollars, for instance. If you have $100 exactly, and you try to do a transaction for $100, but the transaction fee in this case would be 0.00001 cent, even it can be dollars or cent, that transaction simply doesn't go through because, well, you're missing that amount of money. So in this case, obviously, just changing the gas price to 0 will solve that problem for you, but you have to keep that in mind. So let's go explore. So here, obviously, it's going to appear in our most recent blocks, and it's pending confirmation. But from there, we'll be able to see the amount that we sent. Anything like this. There we go. And here, as we can see, we did send 100 Ether from the account FE to the account 62. And here, if you notice, the gas limit we put was 30,000. We used 21,000 of it. So maybe if you're doing something a little more resource intensive than just sending a transaction, you have to be careful with that gas limit. We put a really small one here. And we ended up paying 0.0006 quid. So obviously, it's going to be 100 Ether spent in the eyes of the wallet. But remember that there's that little extra price that you have to take into account. Hello again. Now we finally made a transaction on our blockchain. We're going to explore the different types of transactions that we can possibly do and delve into private transactions, or privacy groups. What we just did was simply an @send transaction. Something I probably failed to mention is the fact that when we did it, you might have noticed that we used the IP address here. And here you could not put localhost. Because if you put localhost, you would have gone directly on your node. That doesn't implement send transaction, but only send raw transaction, which is sort of a pre-signed transaction, if that makes sense. Here, because @signer is signing the transaction, you're going to want to go through your full IP and the port that @signer is deployed on. Now, if you want to do a private transaction, the first thing you've got to know is you cannot send Ether privately. That does not exist. What you can do, though, is call smart contracts. And calling a smart contract is essentially like making a transaction. So for those who do not know what a smart contract is, it's a little bit like a script that runs on your blockchain. It's pieces of code that are deployed automatically on the blockchain. Is like everything on the blockchain, once they're there, they cannot be modified. And from there, they're usually quite short pieces of code because on the blockchain, one things to be efficient, and usually it's an if do. If condition is met, they do something. And to call them, you're essentially making a transaction to their addresses. That's essentially what happens. Now, to do that, you can absolutely call them privately. Now, so there's a bunch of standards we can use. Here, the EEA is the Ethereum Enterprise Alliance standard, which is the one that we'll be using. And here, let's take a look a little bit at the arguments. So first of all, the method we're going to be using is EEA, send transactions, and the parameters. Here, there's the from. So here, you need to send in fact, it's the account number simply. Then the data here is going to be the address of your smart contract. The private from is going to be the ID of your orient node. This is very, very important. This is not the Bezier node. This is from the orient node. So from here, you're going to tell him who it's private for. And as you can notice, this is an array, so you can put multiple people. Well, by multiple people, I mean multiple orient IDs. Obviously, even if you have just one, you're going to want these brackets. And restriction is probably going to be restricted regardless. And here, IP import. This port needs to be the port where the sender, the orient sender, is running. So just make sure that you're matching those. If you want to learn any more, this is where you should go. You should go to docs.@signer. In fact, the best way to do is simply type EEA send transaction on Google. Take this first one, and here, if you just click here, it'll bring you straight here. So this method, here you have a wonderful explanation of what you're doing, what every data field is supposed to be in. And here, if you want directly to copy this, you can. I'm not too sure what smart contract they're calling here. I'm guessing it's probably not going to do anything on your private blockchain. And so from here, you can just run that. Now you have other methods to do it. And if you're going to be running transactions often with the same nodes, a good idea might be to create a privacy group. To create a privacy group, you call priv underscore create privacy group. From there, you put the sets of orient addresses. Very, very important that they're the orient ones, or else it's going to give you an error. Then you can name it. So this name is not any piece of code, so just put a name that you will easily understand, and then you can describe it. So typically, maybe you'd say, hey, this is group something, and the description would be, this group contains nodes 1 and 2, maybe if you're doing a test one. And then from there, once it's created, you're going to get a hash as an answer. So from there, you can copy that hash, and then you can use the EEA send transaction. But all you need to do is to change the private for, which is right here, and you just put privacy group ID, and then you don't need an array. It's just a simple string, and inside you put that hash. But if you lose that hash, there's a way to find it. In fact, let's go manipulate it right now. Okay, let's now send a private transaction. So as we mentioned earlier, we're going to be using this method. So remember, here we use, so I changed it, I realized on the slide it sent node ID. Here you want the sender account. Then you want to send the data, which remember has to be a smart contract's address, what orient node it is coming from, and who is private for, and restriction is restricted. And here you also have to make sure that the sender port matches whoever is sending, obviously. So right here, I put it up here so I could just copy paste it for you with all the right accounts. Here, if we make a transaction. Oh, well, I did 2 of them. I guess that's okay. We have 2 transactions. So same thing here. He'll just give you back a hash that you can explore with. But even if you don't, let's explore this first one maybe. If you look into your recent blocks, there you go, something happened there. And it's going to take a little bit of time to confirm. And from there, you'll notice a fundamental difference. There you go, this whole transaction. Is that this time there's an input data. Last time we were just sending ether, essentially. So there was nothing to put in there. So we had only a bunch of zeros in the input data. Here, because we're calling something, it appears here. So as you can notice, here you have all of this information. And if we look back into our transaction, there it is. It starts with data. So you did transmit something in there, and it matches something being in here. So once again, still gas used and everything, and indeed we did not send any ether, so that is fine. It's not because you don't send ether that you don't use gas. Obviously, what you're doing requires computational power, which has to be paid for somehow. So you're gonna have to pay a little bit of gas there. But as you can see, it's quite negligible. The other thing we can do, I guess maybe we'll do it. I don't know. Is simply create a privacy group by running this exact command. Then from there, just replacing with your orient public keys. I suggest before you have a transaction manager, just opening one of these and making sure that you have your nodes here. So here I did create a group previously that contains orient nodes 1 and 2, and here is its address. But let's say maybe we lost the address. Well, then all you need to do is to go look in the API methods, and there's in there a find privacy group in which you just put the names of, well, the names, obviously the addresses of the orient nodes, and then it's going to tell you which groups contain those. Okay, now we're going to see what all of these private transactions entail. So to do this, I prepared 2 of them for you right here. So they both come from different accounts, but more relevantly, they come from different orient nodes. So both of them are gonna be private for orient 3. One of them is going to come from orient 1, the other one from orient 2. It might be 2 and 3 might have been interpreted, but anyway, they're for the same node, but they come from different nodes. So here, let's run this first transaction. Bam, bam, bam. And all we need to do is to run it here. Notice that because it comes from orient 1, I am giving it to the signer of orient 1. So it's going to run its little transaction there, and it's going to give us a result. So here, when I finally started using my docked network, what I did is I set up 3 signers, so all the nodes could use their own signers. So here, the signer on 7545 is used for orient 1, 7546 for orient 2, and 7547 for orient 3. I had already run these accounts to show you, but I just figured I could do it in live. Up, might want to, there. Let's just reload that. There we go. That sounds a little bit more like it. And if we search, it should still be pending confirmation. As you can see, we're not sending any ether. There's a bunch of data in here. As this is running, I'm also going to be running the second transaction. Now, this second transaction, we cannot run on port 7545 because it's the wrong signer, so he doesn't have the appropriate key. So let me actually run that for you. Let me put, let's say 4545. So here he's going to say, well, I have a problem here. The private from does not match the enclave publicly. The enclave, understand it as the orient, so the orient publicly. So indeed, there is a problem. If I try on port 6, same thing. But if I do it on port 7, bam, he runs it no problem. So there was something to take into account there. So let's keep this in our heads. And here, this transaction is private between nodes orient nodes 2 and 3. And here we're exploring node 1. So if you didn't know what a private transaction was, you'd probably think, oh, well, we're not going to see anything. Well, surprise, we do see something. And when we explore it, it looks just like it, right? It's kind of weird. Even if you search by hash, there's the transaction. The other one was the block. In fact, we can open it right here. Oh, it's true that we can't just click links on lights. But from here, in fact, what is happening is that this transaction is the internal transaction that was done by Orient to keep the blockchain consistent. But this doesn't contain directly any of the information. So that's sort of the private dilemma on the blockchain between having to keep the blockchain consistent and to work like a blockchain is supposed to, keeping all the information, while keeping these private transactions private to whomever they have to be private from. So that's the idea for these. So just to reiterate, these were for EEA. And in fact, if we wanted to, now that I've created this little privacy group, we can maybe run a little privacy group to show. So this group contains nodes 1 and 2. And this is the ID that it gave me when I created the group by running, there it is. By running this, you create that privacy group, and it's going to give you an address just like this, essentially. And from there, we're going to do exactly what it says here. We're going to replace a private for with a privacy group ID. So maybe we're going to do it directly from here. There we go. Privacy group ID. And inside, this is no longer an array, remember? And inside here, we're going to put this privacy group. So now, we still have to tell him who it is coming from. So in this case, if we look here, it's from this account, which I believe is account 1. And if we look after the data, which is quite long, it's still coming from a node. In this case, I believe it is node 1. But it is going to a privacy group, which in this case contains 1 and 2. So let's copy this. We're still ensuring that port indeed matches where we're coming from. 7545 is the signer for 1. And those are invalid parameters, so let's check. Maybe I mistyped private for with privacy group ID. The D is not capitalized. Boom, ID. And finally, we have our transactions executed properly this time. And as you see here, we didn't directly put any of the addresses of the orient nodes we wanted to send to. All we needed is the private group. And if we check out this transaction, there we go. Here, if we check what's happening, we're going to see that there's a block here where something happened. And that's exactly what we did. And inside there's one transaction. And this one transaction happens to be the one we have tagged for. And it indeed comes from the proper nodes and addresses. As you can see, it doesn't use more gas or anything else. So from there, hopefully, you'll be able to do all the manipulations you need, send transactions, call smart contracts, and do whatever you want. So I guess this is going to close out this webinar. I hope you appreciate it. I hope that now you're able to run everything you need to. There's so much more to be done. you're very welcome, first of all, to go look at the API methods, because there's a lot you can manipulate, a lot of methods we haven't even touched on. And then if you want maybe to add some layers to your chain, there's a number of things you can do. So first of all, let's recap what we did, what the tools we're using. Number one, Hyperledger Bezu is an Ethereum client. So I guess even Ethereum would be the layer above. So Ethereum is the blockchain we're using. Hyperledger Bezu is the client. Orient is our private transaction manager, which creates nodes on top of those Bezu nodes. Fsign is a transaction signer, which acts as a proxy between a user and their node. Light is a monitoring tool, which looks at what's happening on one node. And Docker is completely independent, but is a deployment tool that is very, very useful to us. Now, if you want to explore further topics on the blockchain, if you're a little bit comfortable with all of this, number one, you should look into adding nodes, because the blockchain is only as strong as its size, really. Adding some redundancy is going to help the resilience of the system very much. Then you might want to whoa, is it multiplies? Oh, there we go. What I meant here is saying maybe inside one single company, maybe Atlas has a small company in our little scenario. Maybe she could be running multiple validators. Maybe you have somebody's running at the same time validator and a boot node. And it entails a couple things that you might want to explore. And you can do the opposite, as opposed to having one person running multiple nodes. Multiple people can be using one node. That's called multi-tenancy, and it's also a very, very interesting subject. And finally, and what I'm guessing most of the people watching this here will be interested in pursuing, is tokenization. The fact of creating tokens that can represent value or money or objects or intellectual property rights, or all of this is very, very interesting. Tokens are very wide. And if I wanted to guess, let's just add one here in live, and some smart contracts in general. Now that you've interested yourselves in the architectural side, now that you're learning, I think the next logical step is obviously to start deploying smart contracts onto that. And from there, you can do all the tests you want. I will be putting every single one of the resources I used over. So here are the links, but if you don't want to go until here, they'll be linked right below or above. I don't know how we're really going to edit this. I am likely to also put these little notes I use that have like the step-by-step for Apache and things like that, which are a little bit hard to find. So you can have direct resources. You will have everything linked below. So hopefully that's enough for you. Well, thanks so much for sticking around. I hope you learned a lot, and you have a great day. Goodbye.